Good morning. Students are there. Recording it. Good morning. So this is an introduction for sensors and signal conditioning for the 7th semesters. So basically this subject D is a application oriented subject wherein which a number of sensors from all sectors, like from all the disciplines, mechanical, electrical, electronics, and interdisciplinary sensors will be covered in this. And today I will be briefly explaining what exactly it involves. So the first thing is introduction to sensors, then application of sensors. Then the next part is very, very crucial for all the sensors is conditioning of the signals received from the sensors and few applications in video or robotic sensors. So basically, as I mentioned, it is an application oriented subject wherein which it gives you a wide variety of applications to the automotive, manufacturing, aviation, marine, medical, and healthcare industries. So the applications, basically these sensors have the ability to measure multiple various data on the activities taking place within a system or outside the system. For example, if you want to measure the temperature of a ambience or a industry or a manufacturing unit or a furnace or something, you will be utilizing multiple temperature sensors. So the data measured by these sensors can be used in many operating systems efficiently or monitoring of the operations or for abnormalities happening, monitoring and controlling of these abnormalities. So for all these purposes, the sensors are utilized. And in the recent days, the sensors are utilized in, say, for example, the IoTs or almost all the cars and all, robots. So these are the various applications where the sensors are utilized. Now, variety of sensors are available basically for measuring the temperature sensors or proximity, infrared, light sensors. Indirectly, these can be used for measurement of again the temperatures. So accelerometers or smoke, gas, alcohol sensors, these come under the chemical sensors. So pressure sensor, ultrasonic sensor, touch sensor, humidity sensor, flow and level sensors. These are few of the names of these sensors. These are basically utilized in distance, temperature, sound, pressure, proximity, speed, velocity, torque, or gas, especially the oxygen, carbon monoxide, carbon dioxide levels, nitrogen levels for measurement of these, or in agricultural field for measuring the levels of potassium, nitrogen, etc., or acceleration sensors, radiation, altitude, motion, crushing, etc. All these are the applications of sensors. Now the technology, variety of technology are used in building these sensors or utilizing these sensors. Basically the capacitive touch or Doppler effect, electromagnetic, acoustic, electromechanical, infrared or thermal properties, etc. These are the various technologies used in building the sensors. And the applications are in automotive, manufacturing, aviation, medical health, marine. So everywhere the sensors are used. The course, as usual, we have 5 modules. And in the first module, we are going to deal with different sensors, introduction to these different sensors. And in the second module, specifically, we are concentrating on the temperature sensors and their applications in different industries. And the third module, basically, how exactly the signals which are sensed, which will be of very low level, they are going to be conditioned using few of the electronic circuits, simple amplifiers, clippers, clampers, such kind of a things. And even your Wheatstone's bridge is mostly used in conditioning of these sensors. And the fourth module consists of again few of the electronic circuits which are used for conditioning. And fifth module deals with basically the applications of these sensors in different systems like robotics or car parking system. Such examples are there at the block level. So the textbook, one textbook which is used is Sensors and Signal Conditioning by Raman, and other reference books are Soni and Murthy. So these are the books. So why should we study this subject? As these days, all of you are aware that IoT and sensors are the in thing or trendy things. So because of them, uh, to understand how exactly in multidisciplinary arena these are used, to study that this sensor subject is very, very useful. Thank you.
Good morning, everybody. This is Dr. Veena Desai from the Department of Electronics and Communication, professor, and I'm offering this open elective digital forensics as a part of your 7th Sem credit course. To talk about this subject, I'm getting you directly to uh, what digital forensics is all about through my classroom, which was taken for the last year. So let me go in the reverse, chronology. What we generally do here in digital forensics is I will just share. This is the textbook, Computer Forensics and Investigations. The way we have the analog forensic investigation for any crime or murder. Today, as we see, there are a lot of activities on in the cyber world which are happening, and any crime that happens in the cyber world, there has to be some kind of analogous post-mortem which is done, and that is what is the forensics, and that is what the digital forensics is all about. So what is it that we study in digital forensics? Any crime that occurs, first of all, how to take up how to understand the scene of the crime, that is how to understand a digital crime, then how to investigate a digital crime, what are the rules and regulations which are formulated by different countries or territories for digital crimes, for identifying and also procedures for digital crime, then what are the tools which are required for doing the forensic analysis of a digital crime. And finally, we look at digital crimes can be of various ways and in various types on various media. What we are going to explore here as digital, the types of digital crimes are basically crimes that happens on file systems, through file systems, then digital crimes that happen on mobile, and digital crimes that happen on, that is a forensic analysis of crimes that happen on files, mobiles, and cloud. So this is what we understand through this forensics. There would be a small prerequisite, who have understood something of networks or of security that would be required, or the requisite would be prerequisite would be somebody who's really interested in things like identifying crime, so who has slightly a bent of mind towards either understanding how the police department works, or also interested in serials like which have understanding of crime scenes. Okay, so basically I'm getting you to the textbook. Then we do a lot of assignments which are very unique and different. This is what is a part of the course, the way I handle the course. There will be a lot of things to be done as assignments, and very important and uh, good course project which you will have to submit at the end of the course. Also, I appreciate and also encourage students to take part in hackathons. Like this is a data security hackathon, DSCI. So I encourage and also mentor students to participate in such kind of hackathons. The syllabus, if you want to look at the syllabus, I'll slightly share the syllabus here with you. This is the syllabus. So first, we understand the digital forensics as a profession and the investigations, as I said. How do we acquire data? And in acquiring data, there is something called as RAID, or redundant array of independent disks. This is a very important point to be understood, noted, and of significance whenever there is any kind of storage which comes into picture. Then processing crime and incident scene. This is typically the way analog crime happens, and you have all the forensic team coming there, but we now have the crime scene as a computer or a mobile or the cloud. So how do we review it? Okay, so processing the crime and incident scenes. Next, we have these are the tools, as I said, working with Windows and command line interface systems. Very minimal or small command line what do you call commands which are there. This I generally make the students learn and do it for themselves, or there will be your peers who will be giving you not training exactly, but who will do some small presentations on command line interfaces. So a little of DOS or Unix will help, though it is not a necessity. Okay. Then we have case studies for everything, and the case studies are very interesting and typical also. Yeah, one more thing I forgot to mention is we do email and social media investigation. So how are frauds committed in emails, and how to identify what are the frauds or what are the crimes through email and their social media investigation. So of course there is the case study for this in unit 5 comprises, as I told you, of mobile device forensics and cloud forensics. We also have how you use the SIM manager, okay, to read the SIM card messages. So it is all very trendy, very, what do you call, current, and what can directly be applied. And by the way, October is also the month of decide the month as a cyber safe month. Okay, so there is a lot of importance around cyber security, and security is providing security to the data. But forensics is, once a data breach happens, how do you identify the breach, or how do you take the case forward? And that is what the digital forensics is all about. So this is the syllabus. I'll just take you to the kind of assignments that we do so that you get a hang of what would be expected. So this is something like recover a deleted file. This would be very first assignment. Discuss any case study where a digital crime was committed. Establish the forensic evidence which is used. Then the laws that apply to the fraud or the crime scene, and report the verdict given. Okay, so this is one kind of assignment. For people who don't want to do something technical, there's also a non-technical thing, like you can visit a police station to understand the investigation done, and any other activity that involves digital forensics. So this is about one kind of an assignment. You can have same, I mean, you can choose from the assignments. Then there is very interesting course projects which we do. There in the textbook there are a lot of assignments given in the book itself. So some of those will be identified to groups. Of course, all projects, course projects, will be done in groups. So we'll do it in group, and they need to upload the analysis of that in the what do you call, in the classroom. Okay, so this is about the digital forensics. And I also share some supplementary material, like this is the cybercrime investigation manual, which is TSCI, which is our own Indian manual. Okay, so the book is actually authored by an American author, and hence some of the rules and regulations are not relevant to India. And that is how I post what is more relevant to India. And these are certain sample question papers. This is the kind of uh, course presentation that people do. I had students who was doing this. This is a computer science student. This is one which I've done for open elective. We also have it as a course, what do you call, professional elective for the 6th semester students. So this is one of the tools, as I said, Pro Discover. We use this tool to identify how to find out what is the forensic analysis. And these are certain presentations which are done by my students. And this is the kind of class that I take. So there is a demo of ProDiscover and FTK by student groups. FTK is another tool. ProDiscover is one of the tools. So these are all open source tools, which again, there is a demo on the Hex workshop. So all these are done by students itself. Okay. Um, yeah, I also share a question bank at the end to make it just very easy, because the book is very bulky. So that makes it very important. So this is what I had to share with you about the open elective digital forensics. Thank you.
हाँ, ये ओपन करते। एंटायर स्क्रीन है। अब
सर आप इसके बाद करो तो पीसीआई अपडेट लिंक
शेयर ना।
ये चालू कर सकते हैं क्या?
झालं ना। Good afternoon, everyone. This is Nihal Santaji from ENC department. So I'll be handling biomedical system design open elective, which is offered by EC department. So coming to the course details, so this is a open elective course with 3 credits. It carries a total 50 marks of CIE, and a total hours will be 40 hours. So coming to the introduction of the biomedical system design. So basically, this biomedical system this subject gives an overview of different stages of developing or manufacturing biomedical instrument, or developing any this thing. Drugs, or developing any healthcare devices. So it starts basically with the basic introduction of system and modeling. So here we have a in the unit 1 we have a modeling of a biological systems. In biomedical system design, basically we detect or diagnose different diseases, okay, the human diseases. So here basically mm, the devices which we require for diagnosis or detection, we have to develop or manufacture. Okay, for that we have a different stages. So first basically we start with modeling of a biological system, modeling and simulation. So in unit 1, we have taken one model, a muscle model, and eye movement model as example. So we know that there are different health related issues with respect to heart, or brain related issues, or you can say a muscle or a bone related issues. So if I take example of a muscle model, so here the muscle undergoes a contraction and relaxation. So the the physiological mechanism of muscle model is discussed here. So basically how muscle model is developed here. So modeling is nothing but what we are writing a mathematical model, a mathematical equation, and the equivalent electrical circuit we are drawing it. So here muscle undergoes contraction and relaxation. So the contraction relaxation, it is compared with the force. So we are writing the equations, mathematical equations with respect to the muscle model. So with this we can determine we can have a determination of muscle or bone related muscle related issues. So here a simple modeling of a muscle is there in unit 1, and apart from muscle model and eye movement model, we have some ethical issues. So any biological engineer, okay, so basically biomedical system design is an interdisciplinary field where electrical engineer, mechanical engineer, computer science engineer, or electronic engineer play a very important role. All of them play a very important role. So so here uh,
so the biological engineer or the bioengineer who he will be uh, the expert in all these fields. So he has to follow some moral and ethical issues while developing any biological or biomedical systems or any biomedical instrument or any treatment which is given to the patient. Okay, there are some issues, the moral issues or the ethical issues one needs to follow. So biological engineer must follow all the moral and ethical issues. So these are the issues discussed in unit 1. So the two of the moral issues are nothing but beneficence and non-maleficence. So whatever biological engineer he develops or manufactures um, biomedical instrument, that has to benefit to the patient. It should not harm to the patient. So here we have a concept of beneficence and non-maleficence in unit 1. Coming to the unit 2, so that is a basic introduction in unit 1, and unit 2 we have anatomy and physiology. So basic introduction about tissues and cellular organization is discussed in unit 2 initially, and then we have a origin of biopotential. So origin of biopotential is nothing but what, so we have a heart related issues or brain related issues or muscle related issues. Okay, so those how the electrical activity happens in those tissues, okay, will be discussed in unit 2. So how the biopotential is generated. For example, if I take example of a nerve system, okay, how the electric potential is generated in nerve cell, okay, that has been discussed here. Okay, then how do you measure those electrical activity? Okay, there are some techniques. We have ECG, electrocardiogram, we have electroencephalogram, we have electromyogram. So these are the some techniques which are used to measure the electrical activity by the heart or by brain or muscles respectively. So we have a biopotential measurement techniques here. So these techniques are discussed in detail. So apart from this theoretical information, we have a case studies as also in every unit. So even we will be discussing that. Coming to unit 3, we have sensors, a special sensors called biomedical sensors. So these are discussed in unit 3. So here, one of the sensors which I have not mentioned here, ISFET. So we have FET, a field effect transistor, as electronic device. So how we can use that device to sense a sense of physiological signal. So basically, biomedical sensors they detect a physiological signals, and they convert or they give a electrical equivalent output. So that equivalent output voltage or the current quantity has been processed using a biosignal processing. So unit 4 we have a biosignal processing. So we have a different filtering techniques or the noise reduction techniques. So these are discussed in unit 4. So few of the filtering techniques which are very useful in biomedical system design are signal averaging and compression of biosignals. So biosignals which are the signals from the human physiology. So those signals are detected by the sensors, and equivalent electrical signal will be generated, which is given for a filtering. So in unit 4 we have a different filtering techniques. Coming to unit 5, we have got a filtered biosignal, okay, which is given as an input to the core, that is embedded core. It can be microprocessor, microcontroller, okay. So we can decide upon which core can be used for a particular application. So here also we have discussed, we can discuss wearable biomedical embedded systems. So some of the applications of this wearable embedded systems, you know, the smart watch, smart gloves, or smart footwear, or smart headwear. Okay, so these are the wearable devices. A brief will be discussing in unit 5. Okay, apart from the core which is used for a biomedical system, we have a computational or artificial intelligence techniques also in unit 5, which we will be discussing. So the unit 1, 2, 3, 4, 5, all it's those all the 5 units, they discuss different stages of biomedical systems. Okay, so here we have some textbooks and reference books. So so these are already available. Okay, so I will provide you this textbooks or the reference books. Mm, and apart from this 5 units, we have activity. We have a course activity for 10 marks, and we have open book assignment. So for open book assignment, we can take case studies. And for activity, so coming in unit 2, we have a biopotential measurement, ECG, EEG, EMG. So these signals, we can generate it using some database of the patients. So we have a good scope on this activity for this subject. So we have even you can have activity or a mini projects, either hardware or software. Okay, depending upon that, we can conduct some activity on this subject. So here one application I'll show you. So it will give you a brief idea about a biomedical instrument or the device. Play.
What is it?
Play correct.
मैं लेता हूँ. Repeat again.
No, this is video actually. I want to play. Not able to play it. Which will give a brief idea about the application. One application of biomedical. Skip. Close.
PPT.
PPT na. Okay. Correct. Mhm. So this is one of the application to control the wheelchair movement. So either you can control wheelchair movement with hand gesture or using a mobile technology. So with hand gestures, we can control the movement of. This is one of the mini project. So this way you can develop some. You can have some mini project as a course activity, or you can have a get a database from the GitHub or Physionet, and you can generate the different biological signals, ECG signal or EEG signals. This is using mobile. You're controlling the wheelchair. This is one sample application I wanted to show you all. So implementation part is shown here, which is not required. So you can implement such many projects and can have a course activity. Next, coming to the opportunities. So we have cardiac labs which has visited our college. So they have selected, I think, two CS students. So cardiac design labs, basically it is based on the signal processing. Okay. So they install different biomedical instruments in medical institutions. Then we have Bicon, which is a pharmaceutical company, and we have a Samsung healthcare field. Okay, healthcare. In Samsung, we have a healthcare field where also you can work on biomedical devices or biomedical systems. So these are the three companies we have. Apart from that, we have many, but these have visited our college. So coming to the this thing, as I told you, course activity. So I coming to the subject, it's quite theoretical, but you can have a it is basically a brief overview of a biomedical system, how you are developing or manufacturing a biomedical instruments, or how you are developing drugs or healthcare devices. So there are different stages given in this syllabus. You're learning a different units. Okay, will tell you the different aspect of designing a biomedical system. So this is about a biomedical system design subject. And this is quite theoretical. From scoring point of view, it has a few block diagrams and few mathematical equations which are not in detail, but overview of that. So from scoring point of view also, this subject is good, and from a knowledge point of view, at least it is a very good, quite interesting subject. So you all can opt for this, and you can have a very good activity on this subject. Okay. So this is about a biomedical system design. Thank you. Any question?
Yes, good afternoon, everyone. So, myself, Nikhil Inamdar, uh, faculty of ENC department. Okay, so where I'm hosting this presentation to introduce yourself for a open elective floated by the department, which is multimedia processing. Okay, so here to introduce you all to this subject to make your selection better, right? So I need not to explain much for this subject because the name here indicates is multimedia, right? So in this thing, if you just give your attention over the name, right? Media is the way of different medias available in the day-to-day life. So multi is many medias available for communications or for interacting or any a number of applications. So subject name is given as multimedia processing. Okay, but basically the different medias nowadays used to interact, communicate, or send or receive information, or some other applications like security, right? So many other things, and we all people day to day in our day to day life, we are very dependent on these different kinds of multimedia communications. Okay, so like for example, you have your mobile in your hand, right? A smartphone nowadays, right? So which is used to talk. I mean, a voice call you can make by which you can talk to a person on the other distance. Other than that, we have many other add-ons in the mobile now. Earlier, it was mobile or phone is used only for the speech processing or the voice communication, but nowadays it is other than the voice, we have many other things added. This all are many other medias. Like voice is one media. Nowadays, text messages are there. You can write a message, drop a message to someone. So the text is a media, right? And audio messages are also available. Video you can share, you can view videos, you can watch the movies or any other thing which all the video content is there, right? Anything, maybe videos or maybe movie or whatever, right? Text, video, audio, right? Documents, right? So these are all the different medias by which you can communicate to one other, right? So if you see here, I can just a image which gives you the overview of multiple medias available and how they interact, right? So voice is there, messages are there, videos are there, right? So by which you all this using this all these medias you can nowadays communicate, right? So to happen, I mean this communication make it happen. We have to process these multiple medias, right? So if you so for example voice is a communication part, then voice need to be captured in the phone, voice need to be modulated, right? And then it is sent on the network, and on the other side it is received and demodulated. So this is a procedure of a communication, this thing. So likewise other medias which you use, the same thing should happen. Some processing technology should be there, some processing should happen, then only this communication will happen. So we are studying all this about these different medias, its processing, how it will help us to make us communication, right? So this is what all about the subject. Okay, so you have using these medias, all the medias in your day-to-day life. What the thing is, now you have to just understand a little bit technicalities of these things, right? How this happens, how what are the standards, what are the criterias for all this, right? So basically, if you go through the syllabus, I'll just make out the some points from the syllabus, right? So first is multimedia communications. I've already briefed about you, right? We have little bit more detailed study over this. Multimedia information representation, how you represent your information, different types, different forms. That's all. And the third point is important is text and image compression. Okay, so compression is one of the important point here in the multimedia processing or any multimedia applications we study. Right? What is a compression is? It's actually a information what you want to convey or what you want to send on network, right? So that information, whatever may be the type of information, whatever type of the media, maybe text, maybe audio, maybe video, voice, or whatever, it need to be compressed because whatever the size of the information you are sending, if you send it as it is, right? The bandwidth of the network will huge requirement of bandwidth will happen. So in that case, what we do is we compress the information, right, and send it on the network, and on the other side we retrieve that information. Compression should be of, I mean, how much you should compress, so it should convey what is the information you want to convey. The information should not get lost, right? So that should be the compression rate. So that the detail we study in the subject, actually I just want to give you overview why we need to compression. Is compression, without compression, if you use the network bandwidth requirement will be huge. So you have to compress the data whatever is available, and what rate you should compress, that you should not lost its form, I mean it should not lose the information content only. Okay, so whatever is the this thing, it may be text, the image is one more kind of media, right? So text, it may be text, it may be image, it may be audio, it may be video. So text and image and audio and video compressions. So both these points. So whatever is a media type need to compress, and we have different techniques to compress these medias, right? So compression of image is different, compression of audio is different, compression of video is different. So different techniques, different standards. We have H2.61, H2.64. So different standards are there on which we compress the information, and we put it on the network. Right? Okay. For one example, if I give you here in your, if which you have come across in your day-to-day life, you use WhatsApp nowadays, right? So when you share any of the media, like an image, right? So when you capture that image on the DSLR, and the resolution and the clarity of the image, and once you share it on the WhatsApp, right, the image quality will get blurred, or the quality gets downgraded. So that is nothing but a compression. So when you send it on the WhatsApp, this thing, the image gets compressed, and which is be send it on the network, right? So this is one of the simple example which you can uh, think regarding compression. So in the multimedia processing, or in any multimedia application, when you think, you have to think, if you know what is compression, right? What is compression, how you compression, we've done different types of compression and all. And the last point is multimedia information networks, right? So there's a different networks which is used to share this multimedia files. Okay, so like for example LAN, WAN, right? So these are the different examples where you can see. We study these points in detail in the subject. So this is the image gives you the picture of the subject. That's why I've just put this image. I need not to tell you much more here. We can we're going to detail in detail every point in the subject, right, in the syllabus, right? So basically, what is this? This is majorly a theoretical come some numerical kind of subject. Very few numerical, restricted to theoretical. It is block diagram representation, different flows, algorithms, and all will come. Okay, so this is one of, you can study in a communication things, communication engineering. It is one of the important subject. Okay, and nowadays it is very much used domains like image processing, right? So and when we see a machine learning and all out there, we use a different medias. Machine learning, deep learning, we use image, we use video, we use audio. So those medias are applied to those neural networks, how the neural network behaves, the processing of the network, and processing of the source audio or video or image files, and then you can read out something, or you can analyze something, right? Like this, we have a number of applications coming in this field. Right? How you use, how you drag down, which field you choose, that all depends, right? For example, you can have uh, automated system in the house, right, which will operate on the voice, right, which will operate on the commands on the mobile, right? So those all systems have come up now, right? For example, one more example is Alexa, Amazon Alexa. What you use in nowadays, it is all operated on the voice command, right? So voice processing is a thing there, which is again a multimedia processing. Okay, so like this, different kinds of examples we can list out, right? In an industry or in an organization, you can use an information kiosk system which may operate on a voice, right? So like this, you can have a number of varieties of applications you can develop based on different media files, different media applications. So for all that, those different media need to be processed, and that's what we are studying here as the multimedia processing. Okay, you can take up many activities as a course activity of this. You can have different simulation tools, and you can use a different audio video files, and you can simulate them. You can use some, and you can develop some applications, right? So as I said, no, QoS system or an image file, pattern recognition, right? So using a pattern of an image like skin diseases which occur, depending on the pattern, you can detect which kind of disease it is, right? You can use a neural network, you can use image patterns, train it, and then you can use the detection part. So like this, n number of applications you can develop some of the good course activity projects. So all in all, it is all about medias and multiple medias which we use day to day, that we are studying with technicality knowledge, uh, which which will create an interest into this, right? So this is what all about for this subject. So we'll close this presentation, a short presentation on the overview of the subject. Thank you.
Welcome one and all. Myself Dr. Saurabh Mitra, Professor, Department of Electronics and Communication, Engineering, KLS Gogte Institute of Technology. Here is semester 7 open elective for 2022-23. So this course is being offered by Department of EC for all students other than EC students. I'll first give you a brief learning objectives of this course. So like other courses, this course is having 5 modules and 5 course learning objective. So what we are going to understand from this course is the need of modeling of physical, linear and nonlinear systems. So whatever we are seeing around us, there are many systems like electrical, mechanical, there is physical systems, there is financial systems, you can say, economics is there, there are a lot of statistical modeling, there are a lot of social systems. Many systems are going on, and every system is having a certain amount of input and it produces certain amount of output. Why we need to model a system? So that for a certain set of inputs predefined, we can get output of our desired quality. So we want to know how does the system behave. So generally without the system modeling, system is like a black box. We don't know if we give certain amount of input how the system is going to behave. So system modeling will help you understand any system and will help you in modeling the system in mathematical, by using mathematical tools like MATLAB and all. So that for a certain input you will be able to get a desired kind of output. So it's an interdisciplinary course. We have taken system models, or we have taken cases of systems from electrical, mechanical, electromechanical, financial, medical, biomedical, all those things. So statistical, finance, economics, geopolitical, all those things are there. So we are supposed to develop an input-output model for social, political, medical, engineering, business, IT-based system and find interrelationship between the combinational system models. So what are combinational system models? Where we are mixing two different domains like electromechanical system modeling, socio-economic system modeling, brain-computer interaction, which is nothing but medical versus control system kind of a thing, or medical versus data analytics and medical versus computer science kind of a thing. Prey-predator model. Suppose in market one company is increasing or getting success very fast, it is capturing all other companies, and it is getting merged. All other small companies are getting merged with the small company, big company. So what is the dynamics of that whole process, and whether it's good for the customers or bad for the customers, whether there will be a monopoly in the market or there will be a duopoly in the market. All those things can be estimated, found out from this knowledge that is earned from this subject. Share market, it's all prediction based. Okay, better you predict, better earning you can have from the share market. So share market based prediction, it requires database management, it requires statistical forecasting, it requires knowledge of finance, as well as it requires knowledge of geopolitics. So now you can understand whatever systems we are dealing with around us, and we are living in a very fast moving, very highly dynamic and volatile kind of an environment. So in that case, obviously we should know what is a statistical modeling. So this subject is going to help us understand all those dynamics in this very highly dynamic scenario. So determination of nonlinear system models. So mainly in engineering, you are seeing very linear, very easy kind of systems. But around us, whatever systems you are finding, they are nonlinear. So we'll just touch a little bit of nonlinear system modeling, but mainly we'll be dealing with linear system modelings in the field of mechanics, hydraulics, economics, finance, etc. And whenever the system is nonlinear or process is nonlinear, we can linearize it first, and then we can find out its output. So there is a linearization technique that also we are going to learn in this subject by very small numericals. So what is the main objective of this course is develop models for better understanding of different interdisciplinary processes, which will make our decision making easier, which will help us in development of business process model, and which will help us in estimating performance of the systems. So define the controller design technique. So whenever we know how the process behaves, we have to design a controller which will control the process. So controller designing techniques also will be discussed here. For model-based control, optimal control, PID controller, PID tuning technique, Kalman filter-based controller designing techniques. All the things will be learned in this course. So course is not difficult. The topics that is put here, it looks very big. Each topic itself is a matter of research, and Kalman filter as an example. There are no engineering fields where Kalman filter is not used. Okay, so we are not going to go too much depth of all these courses, all these topics, but we will be seeing all these things uh, in basic levels, okay, and we are going to know how to use all these tools for proper system modeling and output estimation. So this is the course content. So module 1, it will be having the very basic knowledge of system modeling, like what are the principles of system modeling, what is wisdom hierarchy, what is bootstrap, what is one-to-many approach, many-to-one approach of system modeling, what is meant by approximation, how does approximation, validation, error analysis helps for better system model development, exponential growth and decay of events, and how to model them. All those things we are going to find out in module 1, which is very common, and that is the introduction maybe for all the other modules. Second module is we are modeling some linear physical systems. So mainly it is electrical and mechanical, electromechanical, thermal, and a little bit of combinational like hydromechanical system, multivariable system analysis and all. So we are going to develop some system model, mathematical model by using this. By the way, do not get scared of this subject. This is not mathematics. Okay, here we are going to use very simple, a little bit of differential equations. Sometimes you are going to use matrix, all those things. So we are not going to solve it. So don't get scared that it is solving of mathematics or it's solution based. No, we just have to apply the very basic first principles of physics, or maybe mechanics, or maybe control systems, or electrical, just to define the process. Okay, so it is not about solving of numerical. There will be no numerical in this course, but using equation, how can you define a process? So the system modeling is the engineering way of defining any system. Third module, this is a little bit deviating from the engineering, because here we are going to see nonlinear economic financial systems. We are going to learn about linearization technique. Economic system we are going to see, economic and finance. There we are going to see supply demand curve of government policies, economic growth of model of a country. How does feedback help in developing system model for measurement and control of national income? So all those things are very realistic, very real life, very physical issues which are driving any country, and those things will be taught here by a little bit of block diagram, and there is no maths as such, so mainly block diagram treatment will be there for this third module. So one case study we are going to see. So this is a case study taken from MBA, how to make money with algebra for buying a car. This also we are going to see in as a case study in module 3. Module 4, so as module 3 is dealing with mainly economics, national income and all those things, money making. Module 4, it is talking about biological, social and decision making models. So here we are going to see the mathematical models for diabetes, human brain information processing system, modeling of ACIR. Okay, that is actually how the COVID propagated or any contagious disease propagated. That model we are going to find out through ACIR. Then model of growth of cancerous cell in human body. So what is the logic behind that? Chemotherapy, how does chemotherapy helps in cancer reduction? So all those basic knowledges from mathematics point of view, from system modeling point of view, we are going to learn here. Then computational modeling for arterial biomechanics, that is how the blood flows through the artery, and what happens when the artery gets blocked. Okay, so all those, so these are very interesting things. It is not engineering, but as you are in final year, this is going to add some out of the box dimension in your thinking, and you can have your projects defined on any of these topics. And the project, not necessarily there should be hardware, but it can be a research oriented, or it can be a database oriented, or it can be a model development oriented projects also. I can help you there as well. Case study, different societal models for, it is called as a prey predator model. So there are rabbits in the jungle, there are tigers in the jungle. So what should be the count of rabbits in the jungle? What should be the number of tigers in the jungle? So that tigers keep on eating the rabbit. So number of rabbit will not get over in the jungle, because when there is no food, tigers also will die. So this is called as a prey predator model. So what is the dynamics in that? We will see in Lotka Volterra, very famous model, and this model is used in management as well. Resource management in fisheries, same thing. You are putting small fishes in the pond, and after 6-8 months you are taking out those fishes when they get bigger. So what should be the rate of fish insertion and fish taking out rate, okay, in the pond, so that always you will be having yield from that fish pond. Okay, so that we are going to see in this. So population dynamics within a country. So how many people are going out, how many people are coming in, how many people are getting birth, and how many people are dying. Okay, so this four things will decide the rate of increment of population in any country. And finally, a very important thing, because this is also another matter of research, and many researchers uses this tool. This is called as a Markov's decision making model. So there are hidden model, Markov model in any process, whether we are able to find out that model for defining the process. Module 5, so when we in module 2, 3, 4, we have come to know the process. In module 1, we come to know about system modeling. In module 5, what we are going to see is how to control those processes. So you might have heard of PID controller, you might have heard of single loop, multi-loop controller, on-off controller, proportional controller, all those controller, and how to design them, how to tune them. Tune means how to properly design the model parameters of those controller. All those things we are going to find out. So unit 5 is about control, not control system, but controlling of this model for a desired output obtaining. And we will finish this course, we'll finish this module with Kalman filter based design. So here also it will be a theoretical kind of a thing. What is Kalman filter, how it helps in controlling model parameters, getting desired output, we are going to see in module 5 case study. So basics of system modeling, modeling of linear physical systems, nonlinear economic financial systems, biological, societal decision making systems, and controller design. These are the 5 topics that we are going to study in this system modeling. These are the books, and all books are with me in hard copy format. Sorry, in soft copy format. I'm sorry, not in hard copy. And all these books are available. So last year we had a Google Classroom. So as soon as you join this elective, a Google Classroom will be floated. So first you will be finding the PDF of all the 6 books available there, and then you can start your preparation as per as module. So the books, page number, module wise, all these things will be mentioned from all the 6 books. And you can see at the right side, Scott E. Page, the model thinker, that is mainly used for the first module, that is basics of system modeling, is defined based on these books. That is Scott E. Page, the model thinker. And just as a read, even if you are not taking this subject as your uh, open elective, but just as a read material, you can go through this book. This economics book also you can go through. There are certain e-resources which will help you. So this is a parallel study. This is not a part of your course, but parallel study, control system video lecture series by Professor S.D. Agashe. So mechanical, civil, electrical, EC people will get benefited from this. Professor M. Gopal, who is a renowned professor in IIT Delhi, he is one of the stalwarts of control system and its knowledge propagation in India, M. Gopal. And last one is MATLAB based control system PDFs. So there are 10 module notes. It can be found from IIT Delhi website. So all the NPTEL courses and everything is given. Now here is the real-time process. So this is what system modeling is going to do. So this thing we will see again in the course. So left side you find there is the practical world, and right side you can say the conceptual world. So I generally take the example of COVID. So left side, so you can find there is a division in the middle. So left side actually the hospitals, the area where actually the COVID is happening, that is in the left side. And we are getting data about how many people getting affected, how many people getting injected with vaccines and all those things, how many people are dying every day, all those things we keep on getting. So all those data, all those sense data are taken in the conceptual world. So in the right side, this is the world of system modeling, or this is the computer based system modeling. Remember, computer is your slave. By different modeling algorithms, we have to model the real life process into system modeling domain. So you can find your real life processes. System modeling is converting the real life processes into model processes for simulation. And all the observations are taken in the conceptual domain. Then system model is developed from all the observations. Prediction we are doing. So today, this many COVID cases were there. Depending on that, hospital availability, oxygen availability, we are going to predict that tomorrow how many cases of COVID will come or how many people might die. Now, if the modeling is perfect, then whatever we are predicting, in that error will be very less. If the model is not perfect, then we have to go for model validation or error analysis and control. So error analysis and model validation is a process through which we come to know whether the system model is proper or not. Okay, so this prediction is the outcome of system model and observation is the input to the system model. And mathematical model is developed here. So this right side is the conceptual world, left side is the real world. So system modeling is connecting these two worlds by its efficiencies. Why do this course? Because immense scope is there in the job market, in campus placement, in interdisciplinary research. You go in electric and hybrid vehicle, you go in the field of power electronics, or you go in data science, or you can say loan disbursement, you can go in the financial market, national economics, or you can go any other field like hydraulics, and you can say biology or sociology. There is no field where system modeling is not used. So that's why this subject is kept as an open elective, so that any student from any domain can know or can get to know the basic principles of system modeling. And see, if you are an IT engineer or if you are a mechanical engineer, you are having your domain knowledge. But if you know what is happening in the other department or other divisions, then you are having an extra edge over your peers in the job market. So what is the main thing? Main thing is to first develop the system data or mathematical model and then obtain system response or predict it. If your modeling is proper, your prediction will be proper. So heavily uses data science, data analysis, database management and big data. So IES and CS people are also equally welcome to take this course. Mechanical, electrical and civil people, last year they were there with us. Student from IES was also there. 10 students have taken this course last year. All of them passed in the first shot and many of them had scored more than 70. Hardly one or two per person was there in 40s. Otherwise, everybody scored in the range of 60 to 80. So do not worry about passing. Do not worry about difficulty level or mathematics. Just take this course so that it will be giving you some real life mathematical modeling of the real life processes. These are some of the stalwarts. You can see at the top left is one of the best research minds or one of the best mathematician of the world, R.E. Kalman of Stanford University. He was felicitated by President Obama in 2006, I guess, US National Medal for Science and Technology. You can find Richard C. Dorff of University of California, Davis, Robert Bishop. He is one of the very big person in control system. In the right side, you can find Professor M. Gopal, Professor B. Bandyopadhyay, Professor S.D. Agashe. So I have attended class of Professor S.D. Agashe and B. Bandyopadhyay. So B. Bandyopadhyay has taught system modeling to me. Professor S.D. Agashe, I have learned linear algebra from him. So these are stalwarts who are all working in the field of system modeling and all. And next time it can be you. Okay. So just think of it, and we'll be starting this course in the first week of October itself. So see you there. Thank you.